everyone. Today I'm going to present the topic computer vision, focusing on three important recognition tasks, which are image classification, object detection, and instant recognition. Let's understand what computer vision is. Computer vision is one of the fastest growing fields in artificial intelligence. It enables computers to understand and interpret images and videos in a way that is similar to how humans perceive visual information. And in this presentation, we will first understand what computer vision is, then we will explore the concept of recognition, and finally learn how image classifications, object detection, and instant recognition differ from one another. Let's move to the next slide. So yeah, um, now the in this computer vision topic, uh, computer vision is about teaching computers to see and understand images like humans do, right? So first, an image is provided as the input, and the next what the system does is the system extracts important visual features such as edges, corners, shapes, textures, and color information. So the system, after extracting these information, now modern deep learning models automatically learn these features during training. And finally, based on these learned patterns, the model produces an output. The output could be a label, a bounding box, or the identity of a particular object. As we can see in this flow chart, the input would be the image, and the process would be started with extracting the features or patterns, and the output would be the labels, boxes, or the decisions, as I said. Now let's move to the next slide. Okay, what is recognition in computer vision? Now let's understand the concept of recognition first. Recognition, it is the process of assigning meaning to visual data. In simple words, recognition answers the question like, what am I looking at? Recognition tasks can be divided into three major categories. The first is image classification, which predicts the label for the entire image. If the entire image is given, like one image is given, by seeing uh, all the objects in that image, we can conclude that okay, this is a picture of the forest. This because some of the wild animals are present in that image. And second, let's move on to the second task, which is object detection. Object detection identifies multiple objects and also tells us where each object is located. And the third is instant recognition, which identifies the exact object among many similar objects. Now, these three tasks become increasingly more complex because each one provides more detailed information than the previous one. Let's take the example like, uh, if I tell that this is my dog Bruno with a name tag, then that is instant recognition. But if I give an image of a dog or many dogs are there, so it will just give you one label that dogs are there in that image. But if we want to find a location, like where the dog is present and where the cat is present in an image, then there comes the object detection part. So how recognition works is like it extracts features from the image, as I said, and it compare with learned patterns. Then it will predict the label and make that boundary boxes. Now, let's discuss the simplest recognition task, which is image classification. So, image classification answers only one question, and that is what is present in this image. The model looks at the entire image and predicts only one class label. For example, if an image contains a dog, we have already discussed this example. Again, we'll discuss it. Then the model, if an image contains a dog, then the model simply gives you the output as dog. It does not tell us where the dog is located, nor can it detect multiple objects. It only predicts the overall category. The process starts with an input image. The image is converted into pixels. Next, important visual features such as edges, textures, and shapes are extracted. Now, the traditional computer vision methods require humans to manually design these features. And as we said that in image classification, it only answers the question that what is in this image and nothing else. The location, like what else are present in this image, whichever is the dominating object, that will be the single label image classification's output. So, if we talk about some popular traditional techniques, that will include SIFT, which identifies key points that remain stable even when the object is rotated or resized. And another method is HOG, or histogram of oriented gradients, which captures edge directions and object shapes. After extracting features, machine learning algorithms such as k-nearest neighbor or support vector machine classifies the image. Today, however, the modern approaches have arrived, so most of the systems use convolution neural networks or CNNs and networks such as YOLO, Vision Transformer, and Sign Transformer, which will automatically learn useful features from the training data, resulting in much higher accuracy. Despite its simplicity, image classification has one important limitation. It cannot determine where the object is located, as we have discussed earlier. If an image contains multiple objects, such as dog, a bicycle, and a person, image classification usually predicts only one overall label. As I told, whichever object has the dominant features, that will be with the output, and the label will be given as that our same output. Now let's move on to object detection. Unlike image classification, object detection answers two questions simultaneously. First, what objects are present? And now, the second question is, where are those objects located? The output, therefore, includes both the object label and a rectangular box around each detected object. For example, in a street image, the model may detect a car, a pedestrian, and a traffic signal simultaneously, right? So each object receives its own bounding box and corresponding label. Now, the object detection process begins with the input image. The system identifies regions that are likely to contain the objects, and each region is then classified, and finally, a bounding box is drawn around every detected object. Earlier, like the traditional, if we talk about the traditional methods, earlier object detection methods relied on the sliding window technique. In this approach, thousands of small windows were moved across the image at different sizes. Each window was classified individually. Although accurate, this method was extremely slow because every possible location had to be examined. If we come to the modern approaches such as YOLO and SST, these approaches solve this problem much more efficiently. YOLO, which stands for You Only Look Once, treats object detection as a single prediction problem. Instead of examining thousands of windows separately, YOLO predicts all object location and classes in one forward pass through the neural network. This makes it extremely fast and suitable for applications such as autonomous driving, surveillance systems, robotics, and real time video analytics. However, object detection still has one limitation. Although it can detect multiple people in an image, it cannot identify which specific individual each person is. For that, we need the third technique, which is called instant recognition. Now, let's learn about that. The final recognition task is instant recognition, which is more advanced than both image classification and object detection. Instead of simply recognizing an object category, instant recognition identifies the exact object. As I told, for example, we have already seen the examples. Let us take the same example again. The image classification may say that dog is there, but object detection will say that there are three dogs in this image with their positions also. But instant recognition can say that this is my dog Bruno, like the dog's identity. What is the dog's name? So instead of identifying only the class, it identifies the unique identity of the object. The process begins by detecting unique features, visual features, such as corners, edges, textures, and patterns. These features are combined to create a unique fingerprint, also called a feature descriptor. Then the descriptor is compared with previously stored objects in a database. If a close match is found, then system will identify the object. Yeah, so let's discuss about the traditional approaches for instant recognition, which relied heavily on SIFT, which detects stable key points and matches them across different images. And if we talk about the modern approaches, modern deep learning approaches use feature embeddings generated by neural networks. And instead of comparing raw images, the model converts each image into a feature vector. These vectors are then compared using similarity measures. Face recognition systems are one of the best examples of this approach. Even if a person's face appears under different lighting conditions or from different angles, the system generates a similar feature vectors and correctly identifies the individual. However, Instant recognition also has limitations. It requires a database of known objects. If the object has never been seen before, the system cannot recognize its identity. For this reason, it has widely used in face recognition, product identification, logo recognition, and biometric authentication, etc. And to conclude, computer vision enables computers to understand images and videos by extracting meaningful information from the pixel data. And we have discussed the concepts of recognition and learned about these three major tasks: image classification, object detection, and instant recognition. Together, these technologies form the foundation of many real world applications. So, yeah, thank you for listening. Here I'll conclude my presentation.